Math 30-2s, we're going to go over assignment number 2 here. So remember in this, to figure out certain things like the amplitude is always your A value. Oh, just 1 second. Here's your A value, so you're just going to write this out. You got A sine A, or so A sine bracket BX plus C plus D on the outside there. So we're going to use all these. So remember your amplitude is the A value. Your period is related to the B value. To find that out, it's equal to either 2 pi over B or 360 over B. So it's up to you to decide which one you're going to use there. The horizontal translation is going to be C over B, and your midline is related to your D there. So if you know all those based on this equation over here, you should be able to figure this out pretty easily. So the amplitude is really easy. So it's 1, 4, 5, and 0.25. So just the numbers in the front of the sign there. My period, either using one of those two formulas here. I'm just going to use the 361 all the time for this one. Makes it a little bit easier to communicate. So the first one is 360, because my B value is 1. Here my B value is 0.75, so I'm going to go with 360 divided by 0.75. I think I did this previously in a previous assignment. So 480. Here's my B value is 6, so it's 360 divided by 6. So 60 degrees. And this one here, my B value is 5, so 350 divided by 5. 72. Cool. Horizontal translations here, we're going to take our C divided by B. So this one's going to be 4. We're not going to be concerned about which way it's going. You can either, so just put a 4 there. 22.5 divided by 0.75 here. So you have 30. 48 divided by 6. If you want to include the negative in this one, you can. So you can say negative 8. Because that's going to be useful if you want to try to determine which direction it's going. And 225 divided by 5 is 45. Okay. Midline is just the D value. So this is, I'm going to put this as an equation. So y is equal to negative 1, y is equal to 7, y is equal to negative 3, and y is equal to 0. So you don't see a number there, you assume it to be a 0. There you go. Looking pretty good. All else fails is to kind of graph them and try to figure out what they are based on the graphs. So here's a graph of a Ferris wheel in London. The London Eye is going up and down. It's got a max height, you've got a min height, that's 15 meters here above whatever the ground is maybe. You can see that it goes up and then down, back down in 30 minutes. So from a trough to a trough, remember that's your period. So my period, this one is 30 minutes, okay? Amplitude is from the midline to one of the max for the min. So you got to find out where the midline is, or you can just use the math for this one, right? So you got two equations for this. You got max plus min divided by 2, and then you got max, minus min divided by 2. Even sometimes for me, it's a little bit tricky to figure out which is which. So sometimes it's just easier to just type them in. So my max 135 plus my min is 15 divided by 2, and I get 75 for this first one. So that makes sense that that would be where the midline is. So this one was midline. So the other one, the other formula is going to be for your amplitude then. Max minus your min. Yeah, 135 minus your 15 divided by 2, and I get 60. Yeah, if I drew that as a line of 60, you would realize I didn't really quite cut it in half. So this line, y is equal to 75, or actually h is equal to 75, would make more sense. But the amplitude from here to the top, I can either count that now, but I did the math on it, is 60 meters. So I know that one. Okay? If you want to know a little bit more about this, that's probably the radius of the Ferris wheel. The y-intercept is 15 meters. You can see it, just read it right off the graph right there. And that probably just means like the initial height when they get on of the Ferris wheel. The midline, which we already decided, was 75 meters, and the range is my height here, so I'm going to be using h rather than a y, and I'm going to go from 15 all the way up to, that's my min, all the way up to my max of 135. There you go. Determine the equation of this graph now, so knowing everything here. So you notice that they already gave us the C value, so that's good. We're just going to fill in the rest of it. So I have 60 as my A. My B is related to my period, so remember to find the B value. A is your amplitude. I'm just going to write that down here. Your B value is going to be equal to 2 pi over my current period, which is going to be 2 pi over 30. This just reduces down to 1 pi over 15. It says if necessary to the nearest hundredth. So I'm actually going to type it in. So I'm going to go 1 times pi divided by 15. So hundredth is 2 decimal places. So my B value here is 0.21 because it's going to be 209 is going to round up. So my B value is 0.21 T. I'll use the letter T for that one rather than X. I'll use the C value they gave us, and then my midline is my D, right? So my D is my midline. So my midline on this is 75. There we go. We got a nice little equation. The last question here is just use regression. So this one, I'm just going to pull up Desmos here. Regression sheet. Put that in your bookmarks or your tabs or something. You might use it later rather than just trying to find it. And I'm going to use, I'm not going to put the months in there. I'm just going to put in the numbers here on the side. So 1, 2, 3, 4, 5, 6, 7, 8. Oh, let me do it. 1, 2, 3, 4, 7, 8, 9, 10, 11, 12. Okay, you can't see what I'm doing. It's just on the other screen right now. And I'm going to put the temperatures in the Y column. I'll pull this over when I actually get it all typed out. It's a little bit easier to see both screens at the same time. Seven. Sweet. Okay. Oh, I wanted to do this as a sine regression too. Okay, I don't know if I can copy this table, can I? No, I can't copy this table. Okay, so I'm just going to pause. Okay, sorry about that. Come back here. So here's my sine regression. I use the sine regression table to do this. Most of the time we want these to be in radians, so hopefully it's in radians already. That's good. And you could change everything else, but this looks pretty good. So it does look like it follows a pretty good sine regression. So the questions asked here, determine the sine regression, the ABCDs to the nearest hundredth. Okay, so the nearest hundredth, oh, put in the wrong page there. So here's my ABCDs there. I'm just going to write out my sine regression. So the equation is going to be y is equal to a, hundredth is 2 decimal places. So 6.15 sine. And then it says bracket bx. So my b is 0.57x. Then it says plus c. So my c is a negative, so I'll go more minus. Now this might be different if you use it in your TI calculator. The C value might be different, and your A value might be either positive or negative, depending on which one they decided to use. But most of the numbers should be the same. Your A, your B, and your D values should have the same numbers. May not be the same sign. And my D value, bracket, says plus D. So 12.96. There you go. Using the regression, what is the average temperature in London to the nearest hundredth. So my average temperature is probably most likely going to be the line that goes right down the middle, right? So that's going to be my midline, or the medium of this graph. So I'm going to say that this is going to be 12.96. I think it's in degrees Celsius, right? Yep, it's degrees Celsius. That's the average temperature in London. Oh, never mind. That's the average temperature overall. What am I looking for? I'm looking just for February. Where's February? February is, it says here 7.5, but if you use my regression for February, which is the second month, if I go x equal to 2, you notice that the average temperature at February on the regression is not 7.5. It's kind of a trick. So if I use the regression, I actually get 6.85 degrees Celsius. And what that means, you can also say this is 2. I could put 2 into this equation up here if I wanted to. I can go 6.15 times sine 0.57 times 2 minus 2.59. Make sure your mode is in radians if you're going to type this in your calculator like this. If I did that in my calculator here, typed it all out. It's backwards to you, but it is 6.854, etc. So it is the same answer you'd get from the graph. Most tourists visit London during the months that have an average temperature of 13 degrees or higher. Determine the month of the year where the temperature first reaches 13. So I'm going to pull out my calculator here. And I'm going to pull out a line that says y is equal to 13, because remember the y values of the temperature here. So January, February, March, April, somewhere between April and May, right? So 4.5 months later, so that's January, February, March, April, May. So May would be the first temperature. May. The first time, because April, it doesn't quite reach the average temperature properly there. So May. The 5th month. Awesome. Okay, so hopefully that worked for you. Hopefully you did well in that one. And I'll see you in the next video.